Hello, myself is Ashish Kumar Mathur from the Department of Computer Science and Engineering, AIML. So today we are going to discuss about the topic set theory in discrete mathematics. In today's content, we are going to discuss about the introduction to sets and representation of sets. So now let's start with the introduction to sets. But before that, we are discussing that why we use the discrete mathematics in the field of computer science or why we study. So basically, many of the areas of the computer science require the ability to work with from the concept of discrete mathematics, like graph theory, set theory, combinatorics, etc. And with the help of these areas, many computational problems, logical problems can be solved in computer science field. So if we talk about the set, so what is the set? A set is defined as an unordered collection of distinct objects of same type or a class of objects. So basically, what is a set? A set is normally a collection of the elements, and of those elements, two properties will satisfy to uh, clearly specify the sets. So first, it is saying that unordered collection means the elements which are present inside the set. It can be a sequence of the elements, doesn't matter. It can be arranged at any order. So order of the element doesn't matter. And second property saying that distinct elements or objects means the element should be unique, or the repetitions of elements values cannot be allowed. So we avoid the repetitions of elements for in the set. So third property saying that set should be well defined. Well defined means the properties of the functions of the element should be properly defined. Means there are a lots of the sets. There are a lot of elements are present inside the set. So how we differentiate which sets are belonging, which properties of the means how elements are different from belonging to the set one, set two, set up to n number of sets. So those elements are belong which elements are belong to which set. It should be properly set, well defined. So it should be well defined means properties should be defined. So otherwise it will not be a part of the set. Elements are written in curly brackets separated by the comma. So if we write the elements in the set, so it should be written inside the curly bracket, and if more than number of elements are present, so it should be separated by the comma. So I am taking a example. Uh, here is the set S, and inside the curly bracket I will write the elements. So I am taking a three elements, and these elements are separated by the comma. So I am taking a element 3 comma 1 comma 2. Another set is S dash, and the elements are 1, 2, 3. So if we talk about first properties means unordered collection. So unordered collection means the sequence of elements doesn't mean. So here I am seeing that set S, there are three elements. In set S dash there are three elements. So the elements are 1, 2, 3. So as the sequence in set as the element sequence are 3 comma 1 comma 2, in S dash sequence are 1 comma 2 comma 3. But if we can say that both S and S dash are the part of the set. So yes, it can be true that both are the part of the set, because already I discussed that it doesn't matter, sequence of elements doesn't matter. So it will be the part of the set. So whether I will write the sequence 3 comma 1 comma 2 2 comma 1 comma 3 or 1 comma 2 comma 3, it will be the part of the set. So another property saying that it will be the distinct object, yeah, distinct or elements. So I am taking suppose elements 1 comma 1 comma 1 comma 2. So this is here I am seeing that 1 comma 1 two times repeated, so it will not be the part of the set, so we should avoid the repetition of elements. So these elements will set will be equal to the 1 comma 2. So this is a properly well defined set. So distinct means where repetitions of elements don't allowed. So well defined, I'm taking in the next slide. So some basic examples of the sets. First example is even numbers. Uh, Set A. Here I am name set name is A is the set which belongs to the which is its property saying that it consists of those elements which are of even number. So here I am written the elements, that is the 2 4 comma 6 8 comma 3. So these elements are the even number which belong to the set A. So another example is I am taking a set of vowels. So B is the set which in which elements are the part of the vowels part. C part, and third case is the exceptional base. Actually I am taking this case which is not a part of the set. Here I set A, the elements are 1, comma 2, comma A, comma B, comma percent. So it is not a part of the set because it is not a well defined. As discussed earlier, set should be a well defined. So I am taking I am seeing that elements which are present are of mix up, or we can say a mixture of some different types of different categories of elements, like 1 comma D is number is of a number numbers, A comma B alphabet numbers, alphabet series, and percent there it is elements also there, symbols. So we can't properly ensure or we can't give the surety that which set A belongs to the categories of the set. So we cannot identify the property of the of set A properly. So it should not be a well defined. So it is a not a so for the set it should be a well defined, or it should be an ordered collection of elements and distinct elements. Cardinality. So here terms used in the set which is the cardinality. So cardinality is the number of elements present in a set is called cardinality of set. So cardinality of a set means the number of elements exist or present inside the set is called the cardinality of the set. So it is represented by the mod of A set symbols, where A is the name of the set. Here example is set B is there, in which elements are 1, 2, 3, 4, 5, 6. So if we count the number of elements, so here total number of count is 6. 6 elements are present. So cardinality will be 6, and it will be represented as mod of P is equal to 6. P is the name of the set. Another example is S is equal to Z slash by slash Z. Z is a set of natural numbers, and condition is saying that Z is less than equal to 10. So here I'm seeing that directly elements are not written inside the set S. So some properties, some functionalities are given in saying that set there is a number Z. Z is the basically a element that belong to the set S, and which elements will be the part of the Z will be the part of the set S. That is a set of natural. It is saying that it is a part of a natural numbers, and in which numbers are ranging from the 1 to 10, because natural numbers start from 1, and the condition is saying that that is less than equal to 2 sorry 10. So it will be ranging 1, 2, 3 up to 10 number of elements will be there. So the cardinality will be 10. So now the next topic is representation of sets. Sets are represented in two forms. If we represent the sets in discrete mathematics, so it will be represented in two ways. Like first form is roster, or we can say tabular form. In this form of set, we list all the elements of set within braces and separate them by commas. So actually, in this representation, we directly write the elements inside the curly brackets, and those elements will are separated by using the commas. So if we here I'm taking an example, say like saying that set of all natural numbers which divide 36. So if we write the set saying that no those natural numbers which are divisible by number 36. So all the possibilities of according to this definitions, we write all elements inside the set B. So here I'm taking I written the elements 1, 2, 3, 4, 6, 9, 12, 18, 13. So these all are the elements, or these are all elements are the part of the set B, which divides the number 36. So here directly I will write all the elements inside the curly bracket, and I am using the commas to separate these elements. Another example is set of infinite number of sets. So here another series is infinite series. So infinite number of sets means ranging can't be fixed. So ranging the elements should be ranged from the plus infinity to minus infinity. So all possibilities of lying within the range, within this range, elements can be lie. So I randomly I'm taking example minus 4, minus 3, minus 2, minus 4, 0, 1, 2, 3. So these are like represented in roster or tabular form. Next representation is set builder form. So in this form of representation, we list the properties or definition that fulfill by all the elements of the set. It means that yeah, as we discussed earlier in the roster or tabular form, we write the element inside inside the set with, by using the curly bracket or by using the commas. So in this set builder form, we can't write the directly we can't write directly elements, or we can't directly use the elements inside the curly brackets or commas. In this, we focus on the properties or functions or characteristics that we use for a particular set. So if we write the properties according to that properties, we can convert into convert into roster or tabular form by uh, uh, specifying that properties for a particular set. So it can be a type any type of properties according to the requirements. So here I'm taking an example is set A is there, in which property is specifying that x is the name of the elements, or we can set of elements that will be the part of the set A. And the property is saying that S belongs to the set natural number, and is indicates that natural number. So first property is saying that as belonging to the natural. So all the elements that will be the part of the will be the net will be the will belong to the set of natural numbers. Another condition is saying that x is less than 6. So it is the saying that how many numbers or how many elements will be there inside the set A. So condition is saying that x will belongs to x is less than 6, or it can be written an x semicolon x belongs to n and x is less than 6. So I will taking examples. So x is less than 6 and x belongs to n. N is the indicate that natural number. So here is the set A. Set A is there, in which elements are there x, And according to this property, we can convert into the roster or tabular form. So x natural numbers means natural numbers are starting from the 1. So how many numbers are there? 1, 2, 3, 4, and 5. So up to 5 number we can write inside the set A according to this conditions. So if we write the element 6, so this will not satisfy the condition. So we will not write this element inside the set A. So number 5, if we talk about the cardinality, so cardinality will be 5. So this is the roster form and this is the set builder form. Another example is set B, in which element will be uh, present like 2x. Uh, 2x property is there and x belongs to the integers. And it is saying that it means a set of integers that are multiplied by 2. So all the elements will be there inside the set. That will be numbers of belongs to the set of integers numbers, and those integers numbers which are belonging to the like a set x, and these numbers will be multiplied by the 2. So here I am taking a x is equal to, it will be integer, so 0 can be integers, part of the integers 1, 2, 3, and so on. So B, inside the set B, so what will be the element present? So here saying that 2x. So all we integers numbers are there. So we multiplied by all these numbers, multiplied by 2 with all these numbers. Like first elements set 0, integer 0, set integer. So 0 multiplied by 0. So result will come 0. 1 multiplied by 2. So it will 2. 2 multiplied by 2, 4. Next integer is 3. So 3 multiplied by 2, 6. So these will be the elements of the set B. So this is the roster form or tabular form, and this is the set builder form. So basically, in the roster form, we are not focusing on the properties of functioning. We are focusing on directly the uh, we are directly write the elements that will be the part of the set. In the set builder form, we focusing on the properties of functioning, and according to that properties of functioning characteristics, we can convert into we can write in the set in the roster form also. So these are the basic representations of the sets. So, and these are the references that I have taken for this topic. Thank you.